Everyone, welcome to Math 104, Section 5.1, Greatest Common Factors and Factoring by Grouping. Chapter 5 is one of the most important chapters in this entire course because we're using it all throughout Chapter 6, and you'll see factoring in college algebra as well. So we're going to start by finding the GCF of some numbers. So we're going to find the greatest common factor of 24, 36, and 60. So we're going to start by writing out the prime factorization of each of these. So 24 breaks down into 2 times 2 times 2 times 3. And 36, prime factorization is 2 times 2 times 3 times 3. And then 60, we got 2 times 2 times 3 times 5. So when figuring out these prime factorizations, feel free to use your calculator. Just keep dividing by prime numbers until you get it done. All right, now what we're going to do is we're going to look at each of these lists of prime numbers and find the matches in all three. So we've got a 2 in all three of them, so there's one. Got another 2 in all three of them. We also have a 3 in all three of them. And those are all the matches between all three of them. So we'll multiply those matches together. GCF equals 2 times 2 times 3, which is 12. So the GCF of 24, 36, and 60 is 12. Your turn, number 1. Find the GCF of 28, 42, and 56. All right, so there's our prime factorizations. Now we're going to find the matches. Got a 2, got a 2, got a 2, and then we got a 7, and a 7, and a 7. And that's it. That's the only matches between all three of them. So GCF equals 2 times 7, or 14. So finding the GCF of the coefficients of monomials will be the first step. And then we're going to go on to find the GCF of the variable parts. So for example 2, we've got two coefficients here, 6 and 9, and the GCF is 3. So we know the coefficient on the GCF will be 3. Now we look at each variable, and where there's a match, and only where there's a match, we're going to pick the smallest of the two exponents. So for b, we have b to the fourth and b to the third, so in the GCF will be b to the third power. Remember, greatest common factor, common is the key word. It has to be in both of them. So we can't choose 4 because this one doesn't have 4 of them. Now out of the c's, the lower exponent is 1. So put a c down there. The GCF of those two monomials is 3b to the third c. Your turn, number 2. GCF of 8 and 12 is 4. Now look at the a variable, smaller exponent is 2. The b variable, smaller exponent is 2. So we get 4a squared b squared. Now this idea can be extended to any number of monomials, and the process is the same. So there's three monomials now, so we're going to start by finding the greatest common factor of coefficients 16, 20, and 24. So that's 4. Now looking at the x bases here, the smaller exponent is 3. And looking at the y's, we've got a y here, nothing here, so we can't include the y's. The base has to be included in all of the monomials to be in the GCF. So there'll be no y in the GCF. Z's, we have 7, 5, and 8. So 5 is the smallest, z to the 5th. So the GCF is 4, x to the 3rd, z to the 5th. Your turn, number 3. So we're going to find the GCF of the coefficients first. We got a little bigger numbers here, so I'll go ahead and write these out. 18 is 2 times 3 times 3. And 30 is 2 times 3 times 5. And 42, 2 times 3 times 7. So we'll find the matches. We got a matching 2 and a matching 3. So that makes the GCF 2 times 3, which is 6. So 6 will be the coefficient of the GCF. All right, now we'll look at the variables. We got an A in all 3 of them. So we'll select the smallest exponent, and that is 5. So a to the 5th. The B's, we've got the smallest exponent of 4, so b to the 4th. And the C's, there's no C over here, so that's excluded. 6, a to the 5th, b to the 4th. All right, part B. All right, so let's do the numbers first. 27, 3 times 3 times 3, 45, 3 times 3 times 5, and 72. 2 times 2 times 2 times 3 times 3. Let's find the matches. We got a 3, a 3, and a 3, a 3, a 3, and a 3. And that's all the matches. So the GCF, 3 times 3, which is 9. So that will be the coefficient on the GCF, 9. And now each variable separately. Sometimes it's very helpful to write them like this, so it's easy to compare each variable. So we got 9, 8, and 9 here. Smallest exponent is 8, so x to the 8th power. 6, 7, and 6. 6 is the smallest, so y to the 6th. And the z's, 5, 10, and 4, so z to the 4th. 9, x to the 8th, y to the 6th, z to the 4th. All right, now we're going to use this skill to factor a monomial from a polynomial. And notice, first step is to find the GCF of the polynomial. So example 4, we got 6 b to the 4th c plus 9 b to the 3rd c squared. Now we already found in example 2 the GCF, we found that to be 3b to the 3rd c. Alright, so next step, we're going to divide each of those terms by the GCF. And we do that, 6 divided by 3 is 2. B to the 4th divided by b to the 3rd is b. C over c, those cancel. Plus, 9 over 3 is 3. B to the 3rds cancel. We got 1 c remaining. Alright, these two results of the division go inside the parentheses, and the GCF goes on the outside. And there's your fully factored form. You should check to make sure you have no more common factors inside the parentheses. And that brings us to your turn, number 4. Our GCF, we saw from example 3, GCF is 4. Oh, no, we didn't find the GCF before. Well, we'll find it. Okay, GCF is 4, a squared, b squared. Yeah, I think we did find that before. Okay, now we'll divide both terms by the GCF. Dividing out, 8 divided by 4 is 2. A squareds cancel. The b to the 4th over b squared is b squared. Second one, plus 3. A is left over on top, and the b squareds cancel. Alright, so there's our results of the division, and then GCF goes on the outside. 4 a squared b squared. And you should always check. You should distribute in to make sure, go back where we started from. So 4 times 2 is 8. A squared b squared times b squared is b to the 4th. So that checks. 4 times 3 is 12. A squared times a is a to the 3rd. And b squared is up there. So that checks. So just make sure you do that quick distribution to check your work. Alright, we can also do this with polynomials with 3 terms, or any number of terms. So we found the GCF before from example 3 to be 4 x to the 3rd z to the 5th. So divide each term by that. Alright, GCF is going to go up front. And inside the parentheses goes 16 divided by 4 is 4. X to the 5th divided by x to the 3rd, that is x squared. The y's stay, nothing to cancel there. And z to the 7th over z to the 5th, that is z squared. Minus, keep the same signs. 20 divided by 4 is 5. X to the 4th over x to the 3rd is x. And the z's cancel. Plus, 24 divided by 4 is 6. X to the 3rd over x to the 3rd, those cancel. Y to the 6th, that's going to stay. And z to the 8th over z to the 5th is z to the 3rd power. So that gives us 4 x to the 3rd z to the 5th times 4 x squared y squared z squared minus 5x plus 6 y to the 6th z to the 3rd. And that brings us to your turn number 5. And we already found the GCFs of these. So we'll divide each of the terms by the GCF. 18 divided by 6 is 3. A to the 5th cancel. B to the 6th over b to the 4th is b squared. And c to the 8th stays. Three divided by 6 is 5. A to the 7th over a to the 5th, that is a squared. B to the 5th over b to the 4th is b, and c to the 12th stays. Minus 42 over 6 is 7. A to the 9th over a to the 5th is a to the 4th, and b to the 4th cancel. So we got 6, a to the 5th, b to the 4th, times 3b squared c to the 8th, plus 5, a squared b c to the 12th, minus 7 a to the 4th. All right, part B. All right, GCF is 9, x to the 8th, y to the 6th, z to the 4th. All right, now we're going to divide each of these terms by the GCF. Negative 27 divided by 9 is negative 3. We have an x left over. Y to the 6th cancels, z to the 4th over z to the 4th, those cancel as well. So negative 3x. All right, middle term, 45, negative 45 divided by 9 is negative 5. Now x to the 8ths cancel. We got a y left over. And z to the 10th over z to the 4th is z to the 6th power. All right, last one. 72 divided by 9 is 8. X, y's cancel, 1 z left over. So there is the fully factored form. And if you end up pulling out a a negative 9 instead, that's fine. You just switch the signs on all of these. All right, now we're going to work on a technique that's going to be very important for what we're going to do next. And it's factoring out binomials from expressions. So not only can we factor out numbers and variables, we can factor out actual binomials. And that's going to be essential for factoring by grouping. So let's say we have an expression like this, 6x times x minus 1 plus 5 times x minus 1. So what factoring is we're removing the things in common. So the two things, or the one thing in common between these two terms is the binomial x minus 1. So we're going to remove that from these two monomials and move it out front, just like we did with the GCF over here. All right, so x minus 1 goes out in front, and now we're going to have something in parentheses here. So what's left over once we remove the x minus 1s? We have 6x plus 5. And there's the factored form. So what we could do is distribute. I could distribute x minus 1 into 6x to get 6x times x minus 1, and then into 5 to get 5 times x minus 1. So when we do the reverse process, we're right back where we started. Your turn number 6. All right, the matching part is 5x minus 7, so we're going to pull that out front. And what's left over once we remove that is 2x minus 9, so that goes in the other parenthesis. And there's the fully factored form. Next technique is called flipping binomials. And this is a surprisingly useful technique. It comes up fairly often. So let's say we've got a binomial x minus 1. And I'm going to go ahead and factor out a negative 1. Put that out front. You can just write it as a negative sign as well. Just put the negative out front. And when I factor out a negative 1, that's going to change the sign of both the terms inside the parentheses. So the positive x becomes negative, and the negative 1 becomes positive. Well, now we're adding two things together, and adding is commutative, so we can always switch the order. So I'm going to do that, and that turns into 1 minus x. Oh, what happened here? From this binomial to this binomial, all we did was flip the order and put a negative sign out front. Keep this in mind. If you ever need to, let's say you need to cancel some binomials, one on top of a fraction, one on the bottom, and they're in reverse order, you can use this property, flip the binomial, and cancel, leaving just a negative sign behind. And that's something that will be very useful going forward. All right, now we're going to factor by grouping. And factoring by grouping involves taking a 4-term polynomial and splitting it up into groups of 2 terms and factoring those separately. Oops, skipped ahead. Didn't do example 7 yet. All right, so 3x, 2x minus 1 plus 4 times 1 minus 2x. Okay, so here we've got 2 binomials in reverse order. So we're going to, in order to be able to factor these out, we have to get them to match. So I'm going to use this little trick here on this one. going to factor out a negative 1, and then reverse the order. 2x minus 1. All right, now 4 times negative 1 is negative 4, so it's going to turn this into subtraction. So we got 3x times 2x minus 1, minus 4 times 2x minus 1. Now we have matching binomials, so now we can factor them out. So I'm going to factor out 2x minus 1, and leaving behind 3x minus 4. And there's a factored form. So without flipping that binomial, we would not have been able to factor it. Your turn, number 7. Alright, so factor out a negative 1 there. Flip that binomial. Now multiply this out. Negative 3 times negative 1 is positive 3. That turns into plus 3 times 4x minus 7. Now we can factor out 4x minus 7. And what's left behind is 5x plus 3. And there's your factored form. So let's take a look at this 4-term polynomial. B to the third plus b squared plus 3b plus 3. So we're going to factor this. And we're going to do it by factoring first the first 2 terms. So the GCF of b to the third and b squared, we take the lower of the 2 exponents, that's b squared. So I'm going to factor out b squared and get b plus 1. Now over here, the trick is I want to factor out something so that I get a matching binomial. Well, if I factor out 3, we get b plus 1, so the binomials match. If you get here and you have matching binomials, you know you're on the right track. All right, now we can factor out b plus 1, and that leaves behind b squared plus 3. All right, now we should check to make sure back to where we started. So let's FOIL. B times b squared is b to the third. B times 3 is 3b. 1 times b squared is b squared, and 1 times 3 is 3. So that checks. Your turn, number 8. So out of the first 2, we can factor out x squared, get x plus 4. And over here we can factor out a 2, get x plus 4. All right, we got our matching binomials. Let's factor those out. X plus 4, and that leaves behind x squared plus 2. All right, check. X times x is x to the third. X times 2 is 2x. 4 times x squared is 4x squared, and 4 times 2 is 8, so that works. Some polynomials will have more than one variable, but it works the same way. So on this first one, greatest common factor of 2 and 6 is 2, so we'll factor that out. And they both have an x, so we can factor that out as well. That leaves behind y minus 3. Now over here, we can factor out a 7. Now if we factor out a positive 7, that's going to leave behind negative y inside the parentheses. So make sure we're going to match here. So instead of factoring out positive 7, we're going to factor out negative 7. And that gives us y minus 3. So now they match. So if you ever get a binomial over here that has the same terms but opposite signs, then you need to switch the sign here on what you're factoring out. That'll switch the signs inside the parentheses and give you a match. All right, you got y minus 3, and then once we remove that, what's left behind is 2x minus 7, so that goes over here. And there's your factored form. And that brings us to your turn, number 9. All right, we're going to factor this one first. 2 terms here. Factor these, we're going to factor out a 4x. That gives us x plus 2. All right, now over here we want to end up with an x plus 2. So we're going to have to switch this one to positive. So that means we're going to have to factor out a negative. And we'll factor out negative 5a. And we take a negative 5a out of this one, that leaves behind a positive a. And over here, negative 10a divided by negative 5a is positive 2. Oops. I have to write an x there. Okay, so now we've got matching binomials. So now we're going to factor out the x plus 2. And what leaves behind is 4x minus 5a. X plus 2 times 4x minus 5a. Part B. So out of this one, we can factor out 3x squared. And that'll give us 2ax minus 5. All right, now we want to match 2ax minus 5 over here. So that means we're going to have to factor out a negative 4. All right, negative 8ax divided by negative 4 is 2ax. And 20 divided by negative 4 is negative 5. So now we got our matching binomials. Now we'll factor this out. Bring that up front, 2ax minus 5. Leaving behind 3x squared minus 4. Now, not every 4-term polynomial can be factors as presented. Sometimes you're going to need to rearrange these things. All right, so let's say we try to factor this as is. Let's see what I can factor out here. There are no variable parts, so I can factor out of the 10 and 18, I can factor out a 2. And it gives us 5x squared y squared minus 9. And then over here, I can factor out a 3. And it gives me 5y squared minus 4x squared. Okay, now we have a problem because these don't match. So we can't go any further with this method. So we need to rearrange the terms. And I'm going to rearrange them in a way that gets some matching variable parts next to each other. So I'm going to try, let's see which way I did it here. Yeah, I can either move this one over or this one over because we match either x squared or y squared. So I'm going to move this one over. So I got 10 x squared, y squared. Actually, I did it that way in the example. I'm going to do it the other way. Minus 12x squared. And then over here we've got plus 15y squared minus 18. All right, so now they're arranged, so we got some x squareds next to each other. I'll be able to factor those out. So I'm going to factor out 2x squared. That leaves behind 5y squared minus 6. All right, now over here, you can factor out 3 and get 5y squared minus 6. So there they match. Now we'll factor out the matching binomial. And that leaves behind 2x squared plus 3. Now in the example, I did it a little bit differently. I moved the 15y squared over. So that just, and I got the same answer. So that just shows there's going to be multiple ways to solve these. Your turn, number 10. All right, so part A, looks like there's nothing we can factor out here or here. None of them match. So we're definitely going to need to rearrange these. So I'm going to move this one over. Do xa plus xb minus, and when you write these, it's helpful to have them in the same order. That way you don't have to do the binomial flipping. So let's try to look a little bit ahead. I've got the order is AB, so I want the order to be AB here. So I'm going to go minus YA minus YB. All right, got the same order there. So that'll make things a little bit easier. Now we can factor out an x here and get a plus b. And here I can factor out a negative y and get a plus b. So that gives us a plus b times x minus y. Part B. All right, we're not going to be able to go very far factoring as is, so I'm going to move this 3p squared over. So I got 2kp squared minus 3p squared. And then the first term here has a k, so I want the first term over here to have a k. So minus 4k, then we'll finish off with plus 6. Now here we can factor out p squared and get 2k minus 3. And over here, we want the first term to be positive, so I have to factor out that negative, and I'll factor out negative 2. And it gives us 2k minus 3. So there's our matching binomials. We can factor those out now. 2k minus 3 and p squared minus 2. Now in any factoring problem, the first thing you should always do, no matter what technique we're working on, is look to see if you can factor out the greatest common factor from the polynomial first. No matter what technique we're using, that is always the first step. Because many of these techniques will not work unless you factor out the GCF first. And some of them will work, but they're a lot harder if you don't remove the GCF first. So, very beneficial to do so. So in the next example, we have (12wy minus 24xz) or xy plus 4wz minus 8xz. Now sometimes this GCF will be just numbers, sometimes it'll have variables as well. In this case, there's no term that has You can't find a term that's in all four of these, or a variable that's in all four of these. So we're only going to factor out a number here. We can factor out the GCF of 4. And that gives us 3wy minus 6xy plus wz minus 2xz. And now we can factor inside the parentheses by grouping, just like we did before. Make sure don't lose that 4. We got to keep that. All right. Now I'm going to use brackets here to keep things straight. So out of this, we can factor out a 3y. And it gives us w minus x. And then over here, if we want to get w minus x, we have to factor out w minus 2x. Okay, so we want to match w minus 2x over here. So if we factor out the z, it gives us w minus 2x. All right, now we've got our matching binomial. We're going to factor that out. So 4 stays out front. W minus 2x, don't need brackets anymore because we're going to just have a couple single sets of parentheses. 3y plus c. All right, and there's fully factored form. Your turn, number 11. So out of this one, we have a GCF of 7. No variables in all 4 of them, so don't have to factor out any variables. So we'll pull out the 7. It's 2ac minus 6bc plus 3bd minus ad. All right, now that we have a GCF out, we can factor by grouping on the inside. So keep that 7 on the outside. And on the inside here, we can factor out 2c oops. That gives us a minus 3b. And then over here, we don't have them in the same order. So we should flip those around because I'm going to get a flipped binomial over here unless I change the order here. So that really should have been the next step, be to change the order on those. I'll just do it on this step. So minus AD plus 3BD. Okay, now next step we'll factor there. Now I can factor out a negative D, and that gives me a minus 3B. And now they match. Now we can factor out that matching binomial, so keep the 7 on the outside, a minus 3b, 2c minus d. Part B. We got 12 minus 6q minus 18p plus 9pq. All right, there are no variables in all 4, so we can just factor out a number. We're going to factor out a 3. Gives us 4 minus 2q minus 6p plus 3pq. Now I'll factor this by grouping. Looks like I've got my q's both in the second position, so I think we're going to be okay. So out of here I can factor out a 2 and get 2 minus q. And over here I can factor out negative 3p. And that gives me 2 minus q. So we got our matching binomials. All right, 3 stays on the outside. 2 minus q goes here, and what's left behind is 2 minus 3p. All right, so we've laid the groundwork to be able to go on in this section and master factoring, which is going to be essential going forward in Chapter 6, and factoring is used all throughout college algebra. It may be the single most important skill, so go practice.